Hello, in this part of the video, we're going to look at a different array implementation of sorted list. So remember in the previous array implementation, when we try to shift data, it's kind of painful because you're shifting the big objects down. So although we just use the assignment operator, but that assignment operator is overloaded. So behind the scenes, there's lots of memory allocation, deallocation, copying there. So very busy down there. So now I'm trying to show you we could implement a light-weighted array. So instead of, in our array, in this list, in our array element, instead of keeping track of the data objects, we put pointers to data objects. So individual element of the array is going to be just be pointers. Now think about it. If it's pointers, when we do the shifting, you're only shifting pointers. So it's much more efficient than shifting the big objects there. And now let's take a look at the implementation detail. If individual element of the array is data star, a pointer to data, then the array name should be a pointer to data star. So it will be data star star here. So remember, the array name is just a pointer to the first element of the array. The first element, and actually the rest of the elements are all pointer to star. So this is pointer to star, and this is the first element, which is a pointer to the real data. And this is a data object. To access this data object, d-array bracket 0 is only the pointer to this object. You have to dereference this one. And inside this data object, you have ID, you have name. I only draw ID here. And ID is a pointer to the character array here. So now let's take a look at the implementation. And the private data part is this d-array. And in the constructor, when you allocate this array, you didn't allocate any memory. You see, when you allocate the array, you only allocate for the array. You didn't really allocate the data objects yet. You see, the array contains pointer to data objects. So in the insert function here, when you try to insert a new data, you say d-array bracket I. Remember, it's a pointer to the real data. Then you create a new data. So that's some implementation detail I want to point out. And also imagine for the D structure. For the D structure, you cannot just say delete array. You cannot just go ahead and delete this array. Let's see. So if you say I just delete this array, you say delete the array, that will be horrible, because after you delete this one, you lose a pointer to the real object, lots of objects there, and they all become garbage. And so what we need to do is we need to first delete those objects. You could have lots of those objects there. First delete those objects, loop through the array, delete those objects, and when you delete those objects, that means those objects' lifetime is over, and the D structure for each object should get invoked, and it will first delete the dynamic memory allocated by that objects, then delete that objects. After you delete all those objects, you can delete this array. Alright. Thank you.